Hi everyone, my name is Michael. I go by compukidMike, and this is the Badge Talk for the Car Hacking Village. The Badge team consists of me and my wife. She does all the design and graphics work, basically all the pretty parts of the badge. I do the electrical side of it. These are some of the badges we've produced in the past. The Goonbox badge, the sonic screwdriver, and the little TARDIS. And then that was a couple years ago. Last year we did the bow ties and another sonic screwdriver, as well as the Fifth Element badge. So this year, the Car Hacking Village contacted us and asked us to do their badge. And so this is what we came up with. Lots of blinky lights, which is of course the most important part. And then this year the Car Hacking Badge is an automotive Ethernet media converter. So, what is automotive Ethernet? It's similar to regular Ethernet, but it runs over a single twisted pair instead of 2 to 4 twisted pairs like regular Ethernet. Underneath, it's pretty much just a different PHY chip. Couple differences: it runs at a fixed speed, doesn't do auto negotiation, and then there are primary and secondary sides to the connection. So it's not universal like normal Ethernet. And it's made to handle an electrically noisy vehicle environment. So here's a little bit of the difference on the actual electrical interface for it. This is what's called, generally referred to as the magnetics for a regular Ethernet connection. And then here for automotive Ethernet, you can see it's very simplified. You got the choke here, a couple capacitors, and that's it. Now, when I say that's it, I don't really mean that, and we'll get into that a little bit later about how datasheets tend to leave things out or say the wrong thing. So, how to use the badge. Everyone who got a badge should have gotten this instruction sheet. So obviously USB connector, power switch here. Flip it to the top to run on batteries, bottom to run on USB. When you turn it on, it will be in one of the blinky modes. Press the mode button over here to cycle through those. There are 4 different ones. Once you get through those, it will go into the Ethernet modes. Now, when it's in those, only these bottom lights are going to turn on, and not all of them. So there are 4 different Ethernet modes, and as you click through them, you'll notice the left and right LEDs here on each side change. And so what that's doing is changing port 0 here, these 2 pins, and port 1, these 2, changing whether they are set as the primary or secondary side of that connection. So that's important for when you're connecting it to like an ECU in a car or a camera, other Ethernet peripheral, right? It matters if each side is set as primary or secondary. There needs to be one of each. If they're both sides are primary, they won't talk to each other. Same with secondary. And then the center LED here will tell you if that automotive Ethernet port is connected or not. So port 0 here on the left, these 2 pins connect to this RJ45 jack over here, and then P1 over here to P3. And so there are 2 completely separate automotive Ethernet media converters. So maybe wondering, using some words that maybe might be weird, media converter means it's simply converting between the 2 different physical versions of Ethernet here. So automotive Ethernet is just a different physical connection between devices. Behind it, the protocols are all the same as regular Ethernet. Same data goes across and everything. It just runs over this single twisted pair, and so it's a little bit different chips here. So the badge transparently converts between the 2. If you wanted, you could even connect one computer in here, bridge these across between port 0 and port 1, and connect another computer here, and this badge will convert the Ethernet twice, from regular into automotive and then back. And so you can communicate through the badge that way. Not that that's super useful, but it can be done. So the board was designed in KiCad, and We also used Inkscape and CorelDRAW for the artwork, and a plugin called SVG2 Shenzhen. And that is an Inkscape plugin that makes board artwork for KiCad really, really nice, and it's an awesome tool. Here's the schematic for the board. This is on our GitHub, link down here. And you'll notice this big NDA block in the middle. We'll get into that a little bit more later, but needless to say, NXP has put the automotive Ethernet chip info under NDA. Firmware was developed in NXP's MCU Espresso IDE. It works fairly well. It's an Eclipse-based IDE. It is cross-platform and it's free. As for the actual firmware, it's not open source at the moment. Again, NDA issues. We're trying to work with NXP on that and see what we can and can't release. So hopefully we'll have more info on that later. So, tools. We made a couple tools to do this badge. One of them was a testing jig. So one of the issues we run into is you got these big Ethernet jacks that go on it and a battery holder, and once all that stuff is on there, it's very hard to fix any issues with the boards, any solder connections that are messed up, anything like that. And so this testing jig, all these little points are little spring-loaded pins so that we can press the board down on here before all the big connectors are on it and test to make sure it works. And so we'll plug network cables into these and run them to a couple computers so we can talk back and forth to the badge and make sure everything's working right. Here on the bottom you can see all the connections down underneath. They're super ugly, but so one of the other tools we made was a depanelizer. So the boards come to us like this from the factory, and this is done so that we can run multiple boards through the pick and place machine and through the reflow oven simultaneously. It means less boards that we have to handle. It makes everything a little more efficient. But you have to cut the boards out of these panels. You can kind of bend the boards and break them out, but it's difficult and you risk hurting the board. So I was looking for a good, easy way to do this, and I came across this tool. This is made by Heiko. It's just a manual little nipper, and it cuts those little tabs out. It works well, but it's hard on your hands. We made 250 of these badges. Each of them has 9 tabs to cut, so it's a lot of work. So I got looking around before I bought this tool, and looking for reviews, see if it's even going to work, if it's worth the money. They're not that expensive, about 25 bucks. And I came across a video by a YouTuber named Clow42, and he is awesome. He made a review of this tool about 6 months ago, I think, and so I was convinced. And then I got looking through his YouTube channel, and a few hours prior to me seeing that video, he had uploaded a new video of how he made a pneumatic powered version of this tool. And as part of that, he released the 3D printer files for it. And so I decided that was fate and it needed to happen. So using his 3D printed design, I printed my own. And so this is a little pneumatic cylinder that pulls on this rod and pulls the handle of the tool down. Just removed the rubber handles from it, and we've got a little foot switch that actuates it, and it is super nice, really easy to use. It was a lifesaver during this project for how many boards we had to depanelize. Alright, let's talk about when things go wrong, because they will. They always do. So we ran into quite a few issues with this project, but in the end we made it work. So, NDAs. Like I said before, the automotive Ethernet chip is under NDA. I don't know why There are other companies that make similar automotive Ethernet chips that are not under NDA. So, not sure exactly why NXP decided to do that, but they did. So, it took quite a while to get through the whole NDA process. But once we did, we got what we needed. One of the big issues was that the public data sheet, like what you can get off of DigiKey and Mouser and all the other parts places, doesn't even include the pinout for the chip. You have to go through the NDA process to get that information. It also doesn't tell you what any of the registers in the chip are so that you can control it, anything. All the datasheet tells you is kind of what it does and how big the chip is. So now, don't take this as me ragging on NXP. They're an awesome company. In fact, they sponsored the badge and provided the automotive Ethernet chips and the main microcontroller on the board. So kudos to them. That was awesome of them to do, but NDAs are still a pain. Okay, next thing we ran into is that datasheets lie. So this is from the TJA 1100 datasheet. This is not from the NDA one. However, the exact same diagram is in the NDA datasheet. And you can see this is the physical connection for the automotive Ethernet. You can see the choke and the capacitors like before. Like I mentioned before, that's not all. So there's this section here, and this nice little note that says that it is optional. Now, when you're making badges, you're building them to a price point, right? You're trying to make them cheap enough for everyone to afford it, and you're trying to, make it simpler because you got to assemble and test all these, and more parts makes it harder. And so if a datasheet says something's optional, I'm likely going to leave it off, right? Because these are not devices that we are taking to market, that we are, going through FCC and see all the EMC testing and all that. So we left it off on the prototype. That was a mistake. That is not optional. And if you go into this application hint thing, it's got the same diagram, but without the optional note there. So it is very much required. It doesn't work without it. So that was super frustrating trying to get the prototypes to work before we realized that was the problem. The next one, datasheets sometimes hide important info. So this is for the main microcontroller, and this pin, along with a few others that are like it. So it's got information about it, right? The different things that pin can do, and every one of them says general purpose digital input output pin, and every one of them has a little footnote number here. Now, as I was going through this, didn't notice that this footnote number is different than the rest of the pins. And if you go all the way down many, many pages to find that footnote, it tells you that this is a true open drain pin, which means that it cannot output voltage. It can only connect the pin to ground. That's a problem when you're trying to drive LEDs. So the prototypes had 4 pins that could not drive LEDs, which again is frustrating when it says right here that it is a general purpose digital input output pin. That's not true. Next thing we ran into was default KiCad libraries. So, when you're, making up your schematic and everything, it's nice when there are pre-made libraries like this, right? It looks pretty. It's got all the good stuff on there. It's got all the right pins. Perfect. So put that in there, right? It's got pins R1 through 6, the LEDs. It's great. Only it didn't work. And so after much troubleshooting, I finally got looking at this closer and realized it goes 1, 4, 2, 3, 5, 6, when what I was expecting was 1 through 6. And so 4 of the pins were connected to the wrong pins. So the prototypes have some very nasty bodge wires on them to get that to work. So don't always trust the KiCad built-in libraries. Some of them have things like this. And so you can see I changed it to the proper part number and made my, copied that library, edited it to make it the right pin numbers. And it works on and boards. All right, part availability. So whenever I'm going through doing design for a badge, one of the big things is always make sure that whatever part you're choosing, there's a lot of them in stock, because it sucks when there's not. And so, like normal, I did, and everything was great, and there were tons of them. And then when we went to order the final production run, the RJ45 jacks, there were only 115 of them in stock anywhere. DigiKey, Mouser, everywhere. Luckily, Mouser had already put in an order from the factory to get more of those, and they got to us on the 24th of July. So it was in time, barely. Got them so we could put them on the boards. The battery holders were a different story. They were completely out of stock everywhere, and not estimated to be back in stock until late August, early September, which was not going to work. Keep in mind, at this point, we'd already ordered all the boards and everything, so there was no going back. So I looked on Octopart, which is a really awesome site that lets you put in a part number, and they will show you all the different places that sell it and how much it costs. And so for the battery holder, we went through and scrolled down the list, and there happened to be one random vendor that had a few hundred of them. And I believe they were more expensive than DigiKey or Mouser were, but they had them, and we got them, and they worked fine. We got them on time, so that was a win. All right, manufacturing mistakes. So our production run of blank circuit board or bare circuit boards arrived on July 16th. Right, like awesome. We've got a few weeks to assemble these and get them out. Maybe we can even ship them a little bit early, and it'll be awesome. Except when I opened the box, they had done white silkscreen on the boards instead of black, like I had ordered. So, to the board manufacturer's credit, they did remake them at no cost, which I'm sure was terrible for them because boards are expensive, especially shipping from China is crazy expensive. But they remade them. It took 2 weeks, and we got the new boards on July 29th. So from the moment we got them, we started assembling, testing. We got them all 250 shipped out in 5 days. It was a crazy, crazy week and weekend. But we got it done. And in the end, we made awesome badges, and I really hope everyone likes them. If you have any questions, we'll be on Discord chat. Hit me up, compukidMike, and thanks.